In our previous video, we used the XG5000 programming software to configure our XEL-BSSRT remote I/O bus coupler. Since every remote I/O application is slightly different, there are many different configurations of modules that will be application specific. We need to be able to know where the data is located for any application. In this video, we will discuss data addressing for the BSSRT and the PC software tool that helps us establish these specific data offsets for our deployment of the bus coupler. The BSSRT addresses data locations similarly for Ethernet IP and Modbus TCP. Both protocols use the same data addressing software and have similar data offsets, so this information will work with both protocols. We will start by downloading the data addressing tool. This software is called Addressing for Communication Devices and is available to download from AutomationDirect.com. I have mine already downloaded. I have also unzipped it to a software subfolder in my Downloads folder. When I open the software folder, I can select the Addressing for COM-Devices.exe file, and it will launch the software. The software has a section for the XGT, the XGB, and Smart I/O. We will check the box for XGB, since that is our PLC series, and we can then select the I/O we are using. As we discussed in our previous video on setup, we are going to have an XBF HD02A high-speed counter module, and that will be in slot 0. I can now add that in the software. We will also have an XBE DC32A discrete input module in slot 1, an XBE TN32A discrete output module in slot 2, an XBF AD04A analog input module in slot 3, and an XBF LD02S load cell input module in slot 4. Once we have all of these selected, we can select our unit as either byte or word. The BSSRT uses a 16-bit word as the base level of data size, so all data offsets will be in multiples of 16 bits. Byte data size can be used, but will provide different offset values, so we recommend using word. We can then select Run. The software immediately populates the main field and lists the modules for each slot. We see there is an input size and an output size for each module. We can also see input and output address offsets, as well as Modbus read and write addresses. If we are using Ethernet IP, we will use the input address offset and the output address offset, and if we are using Modbus TCP, we would use the read and write addressing. In our case, we can see that the header for the BSSRT is 2 words of input information. The manual and help file detail this header information. It is used to give status of the various LEDs on the front of the bus coupler and is a great way to give quick, easy diagnostics for the health of the BSSRT. The HD02A high-speed counter uses 22 input words and 2 output words. The 32-point input module uses 2 input words. The 32-point output module uses 2 output words. The analog module uses 6 input words and 1 output word, and the load cell module uses 29 input words and 3 output words. We see the software also lists the offsets for input and output data and our Modbus read and write addresses. This information will be crucial in our interpretation of the I/O information once we start reading this data from a controller.